The game takes place in an enclosed arena. Each player can move freely in 8 directions using WASD. They fire projectiles based on their movement direction. This is handled in multiplayer using the move and fire. When a bullet hits a player, they take damage. If their health reaches zero, they unfortunately die and respawn automatically. This is implemented in Take Damage and Player Died. The movement and shooting are handled inside multiplayer.cs. Movement needs raw keyboard input and rotates the player to face in the direction. Shooting uses a photon RPC, so bullets are created in the same time on all clients. Damage is processed locally and the health value is synced to all players using on-photon serialized view. When health reaches zero, the player responds by resetting position and health. The lobby supports 2 to 4 players. All lobby bottoms work correctly, including creating a room, joining a random room, listing rooms, and leaving a room. Oh, and disconnecting. This is handled in the script multiplayer.lobby.cs. The lobby uses photon callbacks. When we connect to the master server on connect to master, let us enable lobby buttons. Create room and join room. Use photons matchmaking functions. When a room is joined on join the room, loads the multiplayer scene for everyone using photon network. Load level.
Fine.
A full game can be played from start to finish. Players spawn, fight, gain kills, and then end either when someone reaches the kill limit or the timer runs out. The match timer and kill detection run inside multiplayer level manager.cs. The timer counts down and updates. Kills are counted using player.addScore, which Photon syncs automatically when either win condition is reached, endgame is called, and the UI is shown. When the match ends, the winner is detected and announced to all clients. This uses Photon's shared player score system with getScore. The winning player is shown in the UI using the winner text inside endgame. The winner is found using Photon's score system. Each player's score is assessed with getScore. The script compares all scores to find the highest one. The winning player object is passed to endgame and the winner's name is shown in the UI. Each player sees a personalized result message. If you win, you see win. If you lose, you see lose. The logic is handled inside the endgame function. In the endgame function, I compare the winning player with the local player. If the local player matches the winner, then they see you win, otherwise they see you lose. This makes the result message personalized for each client. The winner is calculated using both tally and time. If the player reaches the kill limit first, they win. If the timer reaches zero, the player with the highest kills win instead. This implemented in decide winner by score in multiplayer level manager.cs. The game has 2 win conditions. If someone reaches the kill limit first, I detect it using on player properties update. If the timer reaches zero, I run decide winner by score, which finds the highest score. So both kill count and time influence who wins. At the end of the game, players can choose to play again. The game only restarts when at least 2 players are still connected. Only the master client can trigger the restart. This is done with an RPC, so all players reload the scene. The play again button calls try play again. If at least 2 players are still connected and the host presses an RPC restart match, it's sent to all players. The RPC loads the match scene so everyone restarts together. For the name tag feature, I created a small prefab called player name tag. It contains a canvas set to world space, and inside that canvas is a simple legacy UI text component. In my multiplayer script inside start, I load this prefab using resources.load game object player name tag. Then I initiate it for each player so it appears above their Rhino character. I get the child text component and set it to its values from the photon nickname using name text equals photon view owner.nickname. I also assign a name tag script on the prefab, and that script keeps the tag positioned above the player. It works by taking the 3D world position and converting it to 2D screen position every frame using the main camera. This makes the name smoothly follow the player no matter what they move. For the random player color feature, I gave each player a random RBG color inside the start method of the multiplayer script. The local player generates the color and then sends it to all clients using a Photon RPC call. The RPC function setPlayerColor applies this color to the Rhino's material so every player sees the exact same color on every other client. This makes each character visually unique while still being consistent across the network. Thank you for listening to my video. It's over. Thank you.